Hello and welcome to the final video in our series on engineering the enterprise semantic layer using Metafactory's EIA framework. In this session, we will demonstrate how an AI agent can leverage the business objects semantic model, so-called business object ontologies, to perform neurosymbolic reasoning. You will see how this enables users to ask questions in natural language and have those questions translated into the correct technical paths expressed in the native language of the underlying data sources. Whether the data is stored in SQL databases or JSON-based systems, the AI navigates the technical landscape through the semantic layer we have designed. The result is a trusted layer of semantic documentation that creates a clear and reliable bridge between how the business understands its information and how that information is actually stored and implemented in the physical data world. But first, let's start with a quick recap on what we have seen in the last videos. On the first step, what we've done was creating a business object, in this case, marketing campaign. Later on, we leverage Metafactory's visual ontology modeling features to start defining our marketing campaign business object. Then we leveraged our AI-based agent to continue the modeling and enhancing it. As we can see here, we see the results. A marketing campaign will be described by metadata such as when it started, when was the planned end date, and it would also be linked through semantic relationships to other business objects, such as, for example, here the customers that it targets. Also, a marketing campaign will be described by the communications channels that it was conducted, and of course, the outcomes metrics that it achieved. And of course, it will support a strategic objective. So this example is how we will provide, let's say, a unified understanding on what a marketing campaign is at the business level. In the later video, what we did was, let's say, using Metafactory's physical object import feature in order for us to upload a SQL file and have it represented in RDF. So here is what we can see, the example that we uploaded, a given marketing analytics data warehouse schema. And here we can see its RDF representation of its physical schema. We see that the data schema, let's say data warehouse, will contain different tables, and these different tables will have different columns, and it will also capture the metadata on how these tables are joined through foreign primary key relationships. So this is a snapshot on, let's say, the representation of that data warehouse that we made available now in RDF to leverage and start building the semantic layer. Next, what we've done in the other video was performing a schema mappings. That means we took the definitions from the ontology, such as the classes, attributes, and relationships, and we leveraged, again, AI to automatically map them explicitly to the physical object schemas. Here we can see that we mapped given classes, such as, for example, the marketing campaign outcomes, and we translated these attributes from the ontologies class, and we mapped them explicitly to the columns of the schema, so that, let's say, at the end, we built the semantic bridge. Also, we mapped on how to join different classes, and then these were mapped explicitly against relationships from the ontology. All of this with the purpose of now building the enterprise semantic layer that both human and AI can leverage for reasoning. Coming back to the example, we will continue now with the demo and showcase now how AI will leverage what we've created in order now to answer our questions. So first question I'll start asking will be something such as, where do I find planned end date and lifecycle status information for a given marketing campaign? As we can see now, our question, which could be performed by a given business user that wants to know exactly, in the case that wanted to build a report or a BI function, where exactly let's say, throughout all of those physical stores that might exist in the enterprise, where is this information to be found at the schema level? So at the end, what we see here is the result on what we've created. We see that we have created, let's say, a semantic documentation of the schema, which is now made available through AI. So here we can, of course, continue asking the agent, explain how. And have, let's say, a clear explanation on how these results were retrieved. Yeah. And here we say, in our question, we do have different entities which are defined in the ontology, such as a marketing campaign, which is a class, also attributes such as planned end dates and life cycle status, which are also another attribute. And this is basically what the agent will do. It will leverage the schema mappings that we have created between the ontology and the physical store in order through them to access this information in the physical store according on how we have defined it in the ontology before we map them. So this is a little bit the result, and then of course we can continue and asking a little bit more complex questions. For example, now if we wanted to ask, let's say, for these marketing campaigns, where do I find the customer country code that these target? Yeah, and now, as we will see shortly, this information will be spread not only in the same table, but it will contain mapping first to different business objects, and then it will also need to find the way of traversing these different tables in order to retrieve this information which is asked. And in this regard, we will get it through the join path between those tables that hold this different information for this given concepts. Yeah. So here we can see that in this case, the marketing campaign class was mapped, and then also here the target relationship between the marketing campaign and the customer business object, and finally the country code. Right. So the idea now is that, let's say, we leverage that bridge in order for us to ask a question which is in natural language and return at the schema level in the technical language how exactly we need, where we need to go in order to access this information, which is spread across, in this case, different tables. Yeah. And of course, all of this is great because now we will persist, let's say, in the semantic layer, a clear semantic documentation on what these schemas elements mean. Of course, maybe if it's a developer on the backend who is working with the data, might understand what these columns mean or might have an idea of what it is. But of course, the purpose of all of this is that we will have an explicit map between what this given column name means and what data it holds, because it will be mapped to a unified definition on how the business defines it. And this will provide a layer of trust for us to fully reliably access this data, because it has now, it's backed by a unified semantic documentation, and it's just not simply a random technical definition from whoever created the data source. And of course, this will give us a central point of access to navigate our entire physical landscape through these unified definitions. And lastly, as we also have now the semantic documentation on what on the metadata around these physical stores, now Metis can perfectly also go one step beyond and, let's say, create or leverage that metadata to create a SQL query, in this case, because we're working with a SQL schema, that is made possible to be created through business language questions, because all of the metadata is already persisted in the graph. And because it's persisted in the graph and it's already mapped to those business definitions from the ontology, now we can confidently create or also enable the agent to formulate the syntaxes of a SQL query through trusted business definitions on how we understand our business. For example, here we can ask it to create a query that lists all customer country codes that marketing campaigns target. Yeah. So given in this case that this information is already persisted, of course, the query cannot be executed because there is not, let's say, an access layer here from the agent. However, we can see that the joined query is perfectly created through this SQL syntaxes as the agent has already provided semantic metadata on top of it that enables it with fully traceability to create the query for, let's say, in an MCP context, to be directly executed at the underlying data source level. So this was it. I hope it was helpful, and see you in the next videos.